Fantastic. What is that one? Is this a Skype only? On Zoom. Guys, okay, all good. Okay, what do you guys know about microservices? Anybody? Jatin, you you can answer these things. Microservices. Yeah.
Yeah, instead of developing everything in the same code base, actually, like the services are split and developed separately, and each service has a separate database altogether.
Yeah, that's right. So basically, microservices means, for example, if we take like CRM applications, they are all integrated together as one single piece. Like for example, from the point where sales team takes the, sales tickets or all those things, from sales to promotions to converting a sale to actually like selling the product. Then after that, customer details, maintaining customer details, then also product history and all these things, everything is catered in one piece, which is in CRM. But microservices means they are like mini services you can develop in any language you want, irrespective. There is no language boundary here. You can just develop in any language. A small chunk of code, you develop it, build it, push it to a pipeline, then get it working. So those are microservices basically. So if you see here, that's what it says. Microservices is a software development approach when an application is broken down into smaller, loosely coupled services. Each service runs independently, focusing on a specific function, and communicates with other services using APIs or messaging system. So that's how API calls are. I mean, these microservices are. So you develop a small chunk of code as one service or a functionality, we could say, as a functionality, we develop it, another functionality like that. Then main thing is like we have to integrate all these microservices to get that end-to-end flow. In that case, what we are using, we may use APIs, or we can use gRPC, or we can also use the messaging services like Kafka. So Kafka, RabbitMQ. So those sort of things like we can use. So key characteristics of the microservices: independence, because they are independent. There is no need, like you don't need to be a Java developer or a Python developer. Any developer, doesn't matter. You can develop your service and get it running basically. Single response: each service is responsible for specific business function. For example, we developed it for authentication or order processing or payments. Anything, whatever we are looking for, it would be developed. Decentralized data management: each microservice can have its own database. So basically, every microservice will have its own database, allowing its own flexibility, storing the data. So it's decentralized data. You don't need to have a big database or data warehouse. You can have its own, like that server will have its own database where you store the data. API-based communication: services communicate using lightweight APIs or REST, often REST or gRPC, or messaging systems like RabbitMQ or Kafka. That's that one. Scalability: individual services can be scaled separately based on demand. That means like if you have to add more microservices, we can add more microservices. Or existing microservice, we need to add more functionality to it, we can add that one also. Technology agnostic, that's what it says. Each microservice can be developed using different programming languages, frameworks, and databases. So we don't need one Java developer or one JavaScript developer or a React.js developer. We don't need, there is no like limitation on what sort of developer we want. So that's why it's technology agnostic. Resilience: if one server fails, it doesn't necessarily bring down the entire system. That means like microservices are there. If one microservice fails, doesn't matter. We have the other ones running. So whichever is the one which is failed, independent one, we can look at it as an individual thing. Any question here, or looks like too much of theory part?
That's okay, fine. How it is different from API?
The APIs, yeah. So if you see, APIs are like you send a request to the server and you get the response back. Whereas Kafka is different. Kafka is a messaging service. So basically, messaging system. I'll talk about it in a minute. Once
Uh,
we go through these microservices, then I'll talk about.
oh,
Yeah.
oh,
And gRPC is also a different service because the way it manages API calls is a bit different. So okay, maybe you can read through these ones. Example of a microservice-based e-commerce application. If you have a e-commerce application, instead of having everything like IBM e-commerce or whatever, they have that end-to-end flow inside it, that software. But if you have like many microservices, like a user service, product service, order service, payments, notification, then each one is individual on their own. They are individual on their own, but they can be connected either using a Kafka sort of a messaging service or through an API call. So example here, if you see like user logs in, fetches the data from the database, user selects a product, retrieves from product details page. So all these can be integrated. Maybe let's put this way, microservices we develop first, then we integrate them through an API or a Kafka. Now, what is the difference between this one? Main thing is if we go to the architectural diagram of Kafka, Kafka is a message broker, an orchestrator. It basically what happens is like let's think like there are two people working independently and one person whatever once the job is done, then the person has to tell to the other person I am done with this job. But that person, instead of telling to that other person, he will tell to a middleman saying like my part is done. Then the middleman goes to the next person and says, can you kick off your job? So that is the exact thing what Kafka does. Kafka being a middleman, everybody reports to Kafka saying like, I am done with this work, my part is done. So then Kafka knows, okay, this person's work is done. Let's assign the work to another second person or a third person like that. So Kafka has a concept called as producers and consumers. Producer is the one who are producing the data or generating. For example, a person is adding a product to the cart, and then once the product is added to the cart, then the next thing is uh, this product details like, okay, are do we have enough quantity, or like the inventory, do we have the inventory available with us? So then we need to know, next thing is, do we have the inventory so that we can definitely allow this product to be bought by this customer. In that case, this Kafka basically, the producer will first add to the cart. Then next thing, in Kafka, we have something called as topics. We write everything to the topic. So this person, whoever is like adding the product to the cart, they will say, okay, topic means like a job. To that job, it will tell like, okay, now I added this product to the cart. Then this topic reads, oh yeah, that's fine. You have added product to the cart. Next thing it will, okay, now let's trigger another topic. A topic will be about go and check the inventory. So it will go and check the inventory. So this one, for example, it would be a consumer. A consumer will read through this one, check the inventory. Yeah, inventory is up, all good. We have enough stock. Then it will again send it back to Kafka saying, I have enough inventory. Then Kafka, next thing is, okay, now take the payment. There would be another topic for taking the payment. So it's like every topic will do one job at a time. And the beauty of Kafka is it's like it has multiple sets of topics getting n number of requests. Continuously you are pouring in the request to it, but the main thing is the scalability of this one, and also it is fault tolerant. Like that means like it can handle that many number of requests without any failure. That is the beauty of this one. So to further explain, in simple concept, in Kafka, what we have a producer who sends the request to the topic. Then there is a consumer who consumes the request. So basically, producer and consumer are basically always pinging this topic to see for any updates. So consumer is basically pinging to see, okay, is there any update? If there is an update, okay, let me take it and do whatever action I have to do and respond it back to the topic. So if we further divide Kafka, Kafka will go into it will have Kafka brokers. Each topic, inside the topic, we have partitions. Partition means the place where we can store the data. So let's imagine a person is adding a fridge. Okay, let me store here. A person is adding a TV, store it here. A person is adding some phone or something. So everything is basically stored into this basically partitions we store, and it gives a sequential order in which it stores. And consumer also understands, okay, I've read this 0, now I don't need to read 0, I will read 1, I will read the next one too. Like that it will read through this data inside it. And Kafka broker, basically what it has, it has the server. So if you see here in the topic, we said replication factor equal to 2. That means what we are saying is, for this particular topic, make two sets of copies of this storage, basically of these partitions. So in Kafka broker, what it does, it will create two servers, and inside two servers, it will see, if you see here, it will put the partitions like that over there and over here like that. And then in the first server will become a leader and the second server will become the follower. And if for any reason a leader dies, this is basically we are writing everything from the producer to the leader itself. And if a leader dies for a reason, then the follower will become the leader, and zookeeper is the one who is managing all the servers inside this one. So okay, that's fine. This zookeeper thinks about, okay, that's fine, this person has died, that's okay, let me create another server, and this will make the server 2 as the leader, and it will also create another server as a follower. So that is the role of a zookeeper, which manages the servers inside it. There can be n number of servers again, and with n number of partitions, whatever we define in the topic, based on it, there would be plenty of them sitting here. Any question, confusion? No, man.
No, please go proceed.
Okay, okay. So basically, whatever I told you guys here, like what the producer is the one which is producing the data. Consumer is the one which is listening to the topic and consuming the data. And these topics, basically, our developers are the ones who are creating these producers, consumers, these topics. And these microservices are basically sitting either here or here. So one microservice may be sending the data to a topic, other one is listening to the service. So being an orchestrator, okay, listen to this topic. Okay, now next I know what to do. Kafka knows next step what to do, because we are defining everything in the topic itself. Like what are the next step to do? Okay, give the steps to the consumer. Okay, consumer will take over the steps and do it accordingly. So all the metadata related things are set in the topic itself on how to manage it. So whatever I told you guys just now, I put it on the paper. That's it, over here. So producer basically publishes messages to the topic. In this example, there are three producers of data. Producer one, two, three. That's what was three of them. Let's imagine there are multiple customers making payments, and all these data from producers is written to the partitions inside the topic. So if people are making payments, all these are written into these partitions basically. Now topic, a logical name, will have partitions inside it, which we just talked about, and they are arranged like an array. So partitions are nothing but data storage, and they are like an array which are stored in a sequential order. Each one will store the data coming into it from producer in a sequential order. Example, multiple people are making payments and the data which is coming in. That's what I told. Like as people are making the payments, each one will have respective data. Okay, customer X data is here, Y data is here, Z data is there. So it's like that. It will have all the sets of data there, and from there the consumer can read. Replication factor, which we talked about, nothing but it tells how many servers on this one, these partitions have to be copied. And broker is nothing but the Kafka server, also known called as the node server, where partitions replications are stored. The replications are stored inside this one. Now broker has minimum one leader server and follower, which I just told you guys. There is one leader and a follower. If one of them dies, then zookeeper is the one which is supposed to manage them. Leader server, leader server is the one where partitions read write data happens. So basically, all the read write is happening only here. This is just sitting as a dummy. Until this dies off, it won't do anything. So this is the main one, which read write happens. That's what I told. Like when it fails, then that is happening. And zookeeper plays a crucial role in managing and coordinating Kafka brokers. It acts as a distributed coordination service that helps Kafka maintain cluster state, leader election, and metadata management. So basically, this entire clusters like this leader server. This is one cluster like that. You got several clusters inside the Kafka broker. Now, in terms of the testing, I have done this testing before. It was long, long ago, 4, 5 years ago, or even more than that. So basically, what as a tester, what you have to do is you have to see like whatever the data is going from this producer to the consumer, is it going in the right format? So for that, again, if you guys are familiar with Java, then we can set up all these and then write our test exactly like whatever the producer is going to generate. So if a producer is going to generate a payment system and sends it to the topic, then after that we can go and check in the consumer, because in the consumer those data should be there, or you can go into the database and also check like if the data is coming through across or not. So we can do that things which I'm not covering here. I'm basically covering only about the architectural flow, what happens in the Kafka, how it works. And to finish off, I'll just give you a bit of understanding about this one. Same thing what we talk, but just look at in a real-time example. In an e-commerce application, if you take an e-commerce application, an e-commerce platform like Amazon, Flipkart uses Kafka for real-time order processing, inventory update, and notifications. So like because it's such a popular tool and it's such a fault tolerant, so a lot of big companies are already using it. And they can create these microservices and use it. So architectural flow, let's imagine customer places an order on the website, then order service. So that is the order events. Order service sends an order created event to Kafka. So order is being created. Then inventory service listens to the event, updates stock and publishes to the inventory. So basically like this, we are making all these topics. Order event, basically it's order created, updated, cancelled. All these details are there in the order event state. Then inventory topic, checking for the stock. Then payments, checking if it was a successful or a failure. Notification service, if it is a successful one, then emailing the or like SMSing the confirmation to the customer. If these topics are there, then one will be your producer, the next one will be your consumer, and after this one, then next one will be your another consumer, a producer or a consumer. One of them, they will be playing their roles accordingly. So if you see like just an example for this one order event, for example, a customer has placed an order like this. These key values, if you see order ID 123, user ID, and they bought a laptop, for example. Then Kafka, if it's a Java language, if you see the producer is the one which is having these details and sends the record. This is the one which is sending the record from the producer to the Kafka. So some similar sort of code you would be writing basically in your case. So So, and inventory service, consumer, the inventory service which is consuming because order has been created. Now we have to check if the stock is there. So, consumer record, again, similar sort of code where it goes and updates the inventory status. And then once okay finds it, then it publishes it saying like okay, all good. It sends the response back to the Kafka saying I have inventory for this product. Then Kafka triggers the payment section, and payment section is where they will take the payment for it. And if it's successful, then again Kafka gets the notification and Kafka sends another request sent to the customer saying like okay, successful payment for this application. So basically this is how Kafka works, guys. Any questions? Happy to take it.
If you if you just test this producer to consumer flow, right? Is this enough actually? Like just because we are getting some data from producer and
Yeah,
this is
exactly.
something
That's
commonly they ask in the interview as well. Like how do we test the Kafka actually? Like if we just test the data coming at producer, it's received at consumer, is it enough? Or like are there any other
that
common
is
scenarios?
the main thing which it does. So that's what we need to know. Main thing, as we know, topic names. To the topic,
Okay.
it basically sends the details. But inside the topic, we are not doing much. Yeah. So basically, we would be only checking at the producer end and also the consumer end. Sorry, I forgot. It was in a federal government project where I worked. It was all microservices. And there, when I set up this automation framework for them for these microservices, especially Kafka related, same thing. Okay, the producer, it had a set amount of data, then send it to the Kafka. Once it's sent to the Kafka, next thing I'm not checking what's happening here in here. I'm just checking that consumer which is supposed to get the data, is it receiving it or not? So that's what we were checking and asserting basically some fields inside it. Whatever we are expecting in that data, we were asserting. So that's what exactly I did there. Yeah. So one thing I felt is like it was bit complex to explain the topic because if you look up on the internet, there is like maybe a developer will know about it in detail, but what in terms of the tester, what I was thinking is it always talks about okay producer and consumer, but what is actually happening inside the Kafka broker? There is so much information on the internet. It was confusing, so I thought like let's clarify this one. That's when I created this document, and I thought like okay, let's share it with the team. Okay. Maybe next topic we can talk about gRPC. In a real world also we can check the gRPC. Google API calls basically. For now,
So
if
that
there are no questions with Kafka, then we
I have
can.
one question.
Oh yeah, go for it, Naman. Yeah.
Then, like, if you have test this manually, to use the Postman or what tool do you use to test this microservice?
So you are saying can we test it with Postman this one?
Yeah, yeah.
No, we can't test it with Postman. You need to use some similar sort of unit test what developers do. You have to have write your own automation test.
Right. So
Yeah.
automation is one thing, but you can't do this testing like we do API testing sometimes using API Postman and all. So for this, there's nothing,
No,
no
you
tool to do
can't.
manually.
Kafka services, if I'm not wrong, you can't do that way, I think. Yeah,
Right.
unfortunately
And
not.
for automation, what library do you use?
For Kafka, I don't remember now, but I can share the details later on to the group. I'll share it across.
Yeah, no problem. Thank you.
Yep, yeah. Because this is all automated in the back end, so I don't think it's that easy to check it from the front end at all. And maybe Postman gives us that other options like testing those APIs. Even I saw gRPC, they also allow, I think, nowadays. Previously, they didn't allow. And there was other one, yeah, GraphQL. So they also allow that one. But Kafka, I don't think so.
Is it a similar like a ENS event notification service what we used in AWS or any other cloud platforms?
Basically, messaging service. It's a
Yeah.
messaging service. It basically plays like an orchestrator. Whatever you are getting, sending it to the topic, basically it understands it and accordingly it acts. And beauty about this is, as I said, like millions of sets of data which is coming through those microservices is handled without fault. Without fault. For example, in a API call also, maybe we don't have that fastness and there may be a chance like if you are sending like multiple sets of API calls at a time, there may a chance maybe they may fail. But this one hangs pretty well, so it doesn't fail.
The AWS equivalent is SQS. There is a service called SQS. It is similar to this one itself. It works the same way.
Oh, yep, okay. Yep.
Yeah, SQS, yeah.
Anything else?
Thanks for your time again.
All good, no worries. Sorry
Yeah,
guys,
yeah.
it's a small one actually. I couldn't do a bigger one here, so
No,
it's
no, that is a great insight, Jagan. So
yeah.
thanks for your appreciate your effort.
Yeah, yeah. Thank you. Thanks everyone. Okay then. Nice
Thank you.
seeing you guys. We'll come back with another topic then, basically in testing space, and I'll let you guys know in the group.
Yeah, sure.
Thank
Okay
Thank
then.
you.
Bye.
Okay, bye for now. Bye
Thank you.
everyone. Talk to you guys. Bye bye.
Hey, Jagan, looks like I joined right after you finished.
Yeah, it's a small one here. I have the recording. I'll share it with the group.
Okay, okay. Now I loved the fact that you came up with this topic, and I was planning to attend this, but right at 5 o'clock, I was pulled into something, and then by the time I finished, I joined, and you're like, "Okay, thanks, guys." Swap. I'm like, "Oh my God." What a perfect timing. But anyways, please do share recording, and yeah, this is a great initiative that you have started. Yeah,
Purely
love
this
to
one is nothing to do, not much of testing wise, because I wanted to give insight about this one, how this one is architectural design inside Kafka. This part,
No,
the
yeah, I think that's more important than testing. See, what you're doing is very phenomenal, I would say. This is what is required because you're educating people from tech point of view, and what happens after this is left to the roles and things like that. So
absolutely.
really good, amazing initiative here. Love it.
Thank you. Thanks.
Cool. Anyways, yeah, please share the recording. Happy to listen through,
Sure.
and looking forward to your next sessions like these.
Yeah, let's do gRPC. That's another tough one, tough cookie. So let's look
Yes.
at that one. So we'll look at
Yeah.
that. Okay.
Yes.
All
Okay.
good.
Cool then.
Yeah, thank
Cheers.
you.
And any plans for Holi?
Nothing here. Like I'll
Nothing.
stop. Oh yeah.
Let's plan something.